Welcome to Software Engineering and Project Management course in Information Technology. I am Shyam Deshmukh, Assistant Professor, IT Department, Pune Institute of Computer Technology, Pune. In Unit 2 of this particular course, we will be looking about the requirements analysis. In this particular Unit 2, we will have requirements engineering and requirements analysis. So we will be looking into details of requirements engineering and the requirement analysis. In earlier unit, we have learned several key steps for successful software development through various process models. Each model of the software development process includes activities aimed at capturing requirements, understanding our customers' fundamental problems and goals. These models help to understand the requirements and document the relationships among them. Once the requirements are well understood, we learn how to review them for correctness and completeness. Analyzing the requirements involves much more than merely writing down what the customer wants. We must find requirements on which both we and the customer can agree and on which we can build our test procedures. So, in this unit, let us examine exactly what requirements are, why they are so important, and how we work with the users and customers to define and document them. Before moving into this particular unit, I would like all of you to pause the video, think, and record in your notebook about these two questions. Once you have noted down the things in your notebook, you can resume the video. Then let us compare with upcoming description in the slides. So, requirements capturing. A requirement is an expression of desired behavior. A requirement deals with objects or entities, the states they can be in, and the functions they are performed to change states or object characteristics. Requirements analyst or system analyst is the person performing these tasks. Here you can observe the process for capturing the requirements. The first task is elicitation, which is nothing but collecting the user's requirement, then analysis, in which understanding and modeling the desired behavior is being performed. The next task or activity is specification, in which documenting the behavior of the proposed software system is being prepared. Next activity is checking that our specification matches the user's requirement or not. So basically, here you can see the arrow which is pointing back towards the previous module. Reason being that once the analysis is being done, and if you are not satisfied with the elicitation, then you can again go back to the customer and have a brainstorming discussion, and again you can convert that requirement into a requirement analysis. Again you can convert, again you can use that discussion for the analysis. The same way in the validation, if user specifications are not being properly clear, then you go back to the first stage, and then again have a brainstorming with the user and again follow the same path. Thus, outcome of this process for capturing the requirement is the software requirement specification document. Now let us see what is requirement engineering. To make sure that a software solution correctly solves a particular problem, we must first correctly understand and define what problem needs to be solved. This seems common sense at first sight, but figuring out what the right problem is can be surprisingly difficult. We need to discover, understand, formulate, analyze, and agree upon what problem should be solved, why such a problem needs to be solved, and who should be involved in the responsibility of solving that particular problem. This is what requirements engineering is all about. Let us understand the requirements. Understanding the requirements of a problem is among the most difficult tasks that face a software engineer. Developing a clear understanding of requirements doesn't seem that hard. But doesn't the customer know what is required? Shouldn't the end users have a good understanding of the features and functions that will provide benefit? Unfortunately, in many instances, the answer is no. And even if customers and end users are explicit in their needs, those needs will change throughout the project. The broad spectrum of tasks and techniques that lead to an understanding of requirements is called the requirements engineering. From a software process perspective, requirements engineering is a major software engineering action that begins during the communication activity and continues into the modeling activity. It must be adapted to the needs of the process, the project, the product, and the people doing the work. Requirements engineering, what is it? It is a set of requirements for any engineering tasks. These tasks lead to an understanding of what business impact of the software will be, what the customer wants, and how end users will interact with the software. Who does it? Software engineers or analysts and other project stakeholders like managers, customers, and end users all participate in requirements engineering. Why is it so important? Designing and building a sophisticated computer program that solves the wrong problem serves no one needs. That's why it's important to understand what customer wants before you begin to design and build a computer based system. What are the various steps for the requirements engineering? Requirements engineering begins with inception, elicitation, and elaboration. In inception is a task that defines the scope and nature of the problem to be solved. Elicitation is a task that helps stakeholders define what is required, and elaboration is a task where basic requirements are refined and modified. As stakeholders define the problem, negotiation occurs, like what are the priorities, what is the essential, when it is required. So these are the various steps which are involved in requirements engineering. How to ensure that the work product which is being built is right. Requirements engineering work products are reviewed with stakeholders to ensure that that what you have learned is what they really mean is. Even all the parties agree, things will change and they will continue to change throughout the project. Requirements engineering builds a bridge to design and construction phases. There are many viewpoints about its origin. First viewpoint is that it begins with the project stakeholder, where the business need is defined, user scenarios are described, functions and features are described, and project constraints are identified. Another viewpoint is that it begins with a broader system definition, where software is the one component of the larger system domain. But regardless of the starting point, the specific needs of design and construction must be addressed. The priorities that guide the order in which work is to be completed, and the information, functions, and behaviors that will have a deep impact on the resultant design. Requirement engineering provides appropriate mechanism for assessing feasibility, negotiating reasonable solution to the problems, validating specifications, and managing the requirements. Here is an illustration of a library management case study which you can go through thoroughly. You can pause the slides here. You can read the whole case study in much details, and then we will look into various dimensions of the requirements engineering. Now let's see the three dimensions why, what, who of requirements engineering. The preceding case study descriptions gives us a preliminary idea of the wide range of issues we need to consider in the requirement engineering process. The investigation of the problem domain leads to consider two versions of the system. The first version is system as is, and the second version is system to be. The system as is has problems, deficiencies, and limitations. In case of Eon library system as is, money is wasted by the acquisition of duplicate or rarely used resources. Access to bibliographical search facilities is severely limited in both time and location. The system to be is intended to address those problems based on technology opportunities. It will do so only if the software to be and the organizational and physical components defining the environment are able to cooperate effectively. In the Eon library system to be, The new software has to cooperate effectively with environmental components such as patrons, staff, anti-theft devices, digital libraries, and external library systems. The problem domain may be structured along three dimensions. We need to figure out why a system to be is needed, what needs must be addressed by it, and who in this system will take part in fulfilling such needs. The why dimension. The contextual reasons for a new version of system must be made explicit in terms of objectives to be satisfied by it. Such objectives must be identified with regard to the limitations of the system as is and the opportunities to be exploited. This requires some careful analysis, like what are those objectives precisely, what are their consequences, how do they interact, how do they align with business objectives. Such analysis along the Y dimension is generally far from simple. This requirement engineering dimension is concerned with functional services that the system to be should provide to satisfy the objectives identified along the Y dimension. Such services often rely on specific system assumptions to work properly. They need to meet constraints related to performance, security, usability, interoperability, and cost, along with others. Some of the services will be implemented by the software to be, whereas others will be realized through the manual procedures or device operations. Objectives must be formulated in precise terms and in a language that all parties concerned understand to enable their validation and realization. They should be traceable back to system objectives so that we can argue that the latter will be satisfied. This analysis of the required services, constraints, and assumptions is in general far from simple. Some might be missing, others might be inadequate with respect to objectives stated explicitly or left implicit. Others might be formulated ambiguously or inconsistently. In our library management example, we might visualize a bibliographical query facility as a desirable software service in the Yon library system to be. To enable validation, we should define this service in terms that are understandable by library staff or by the students who would use it. The definition should make it possible to argue that the objectives of increased coverage, information accuracy, and wider accessibility will be achieved through that service. One assumption to meet the objective of anywhere or anytime accessibility is that users do have a web access outside library opening hours. Constraints on the bibliographical query service might refer to the average response time to a query, the interaction mode and query answer format for usability for non-experts, and user privacy. For example, non-staff users should not be able to figure out what other users have borrowed. The who dimension. This requirement engineering dimension addresses the assignment of responsibilities for achieving the objectives, services, and constraints among the components of the system to be, like human, devices, or software. Decisions about responsibility assignments are often critical. An important objective, service, or constraint might not be achieved if the system component responsible for it fails to behave accordingly. For an example, in library management, the objective of the accurate book classification will not be achieved if the department faculty members who might be made responsible for it do not provide accurate keywords when books are acquired in their area. The objective of the limited loan periods for increased availability of book copies will not be achieved if borrowers do not respond to warnings or threatening reminders, or if the software that might be responsible for issuing such reminders in time fails to do so. Till now, we have seen what is requirement and requirement engineering and understanding the requirements, like a case study, a library management case study, and then why, what, and who dimensions of the requirements engineering. Now we will be looking at various requirement engineering tasks. So the number one is inception, a second is elicitation, and third one is elaboration, negotiation, specification, validation, and the requirement management. Let us talk about inception. So inception means start or the beginning. It is usually said that well beginning is half done, but it is always problematic for the developer that for from where to start. Requirement engineering itself is a communication intensive activity. In inception, the aim is to have basic understanding of the problem, to know the people who will use the software, to know exact nature of the problem that is desired from the customer's side, to maintain effectiveness of preliminary communication, to have collaboration between customer and the developer. The developer must ask the following questions: who is behind the request for this work? Who will use the solution? What will be the economical benefits of a successful solution? Is there another source of solution for the same problem? Next task is elicitation. Elicitation means to draw out the truth or reply from anybody. Elicitation is a task that helps customer to define what is required. To know the objectives of the project to be developed is a critical job. The questions: why is it difficult to get a clear understanding of the customer wants? While solving this particular issue or while solving this particular question, the sharer come up with thinking and the perspective of the users and the developers with each other. So let us see how developers see users and how users think about developers. Okay, so developer thinks that user don't know what they want, whereas user thinks the developer don't understand the operational needs. The users can't articulate what they want, and developers can't translate clearly. Developer can't translate clearly stated needs into a successful system. Users are unable to provide a usable statement of the needs, wherein user thinks that developers set unrealistic standards for requirements definition. Developer thinks that users have too many needs that are politically motivated, and whereas the user thinks developers place too much emphasis on technicalities. Developer thinks that user want everything right now, and user thinks that developers are always late. Developer thinks users can't remain on schedule, wherein users think that developers can't respond quickly to legitimately changing needs. The developer thinks that user can't prioritize needs, whereas user thinks that developers are always over budget. Developer thinks that users are unwilling to compromise, whereas the users think that developers know all the time. Developers say no all the time. Likewise, the users refuse to take responsibility for the system, whereas the developers try to tell us how to do our job. The same way, the developers think users are not committed to development projects, whereas the user thinks that developers ask users for the time and effort, even to the detriment of the user's important primary duties. To answer this question, there are again many different problems which exists. So problems of scope, problems of understanding, and the problems of volatility. Let us see the problems of scope. The boundary of the system is ill defined, or the customer or users specify unnecessary technical detail that may confuse rather than clarify overall system objectives. In problem of understanding, the customer or users are not completely sure what is needed. They have the poor understanding of the capabilities and limitations of their computing environment. They don't have a full understanding of the problem domain. They have trouble communicating needs to the system engineer, and they omit information that is believed to be obvious. They specify requirements that conflict with the needs of the other customers or users, or specify requirements that are ambiguous or untestable. Problem of volatility. Volatility means change from one state to another. The customer's requirements may change time to time. So this is a major problem while deciding fixed set of requirements. Let us talk about elaboration task. The information obtained in inception and the elicitation is expanded and refined during the elaboration. This task focuses on developing a refined requirements model that identifies various aspects of software function, behavior, and information. Now, requirement engineering activity focuses on developing the technical model of the software that will include functions, features, and constraints. The elaboration is an analysis modeling action. This model focuses on how the end user will interact with the system. Elaboration is driven by creation and refinement of the user scenarios. User scenarios is parsed to exact analysis classes. The end result of elaboration is an analysis model which is informational, functional, and behavioral in nature. Let us talk about negotiation task. It's usual for customers and users to ask for more than can be achieved given limited business resources. It's also relatively common for different customers or users to propose conflicting requirements, arguing that their version is essential for our special needs. These conflicts are to be handled through a process of negotiation. Customers, users, and other stakeholders are asked to rank their requirements and then discuss conflicts in priority. So, a loose prioritization scheme might separate requirements into three categories, that is, requirements that absolutely must be met, which we call it as essential. The requirements that are highly desirable but not necessary, that is, desirable category. And the requirements that are possible but could be eliminated can be put into optional category. Using an iterative approach that prioritizes requirements, assesses their cost and risk, and addresses internal conflicts, requirements are eliminated, combined, and modified so that each party achieve some measure of satisfaction. Now let us talk about specification task. A specification can be a written document, it can be a set of graphical model, a formal mathematical model, a collection of usage scenarios. A specification can be a prototype or any combination of these. The specification totally describes the functions and performance of the computer based system and the constraints those will govern its development. The requirement specification restates the requirements as a specification of how the proposed system shall behave. The specification also is written entirely in terms of the environment, except that except except that it refers solely to environmental entities that are accessible to the system via its interface. That is, the system boundary makes explicit those environmental entities that can be monitored or controlled by the system. Specification is the final work product produced by the requirement engineering. Let us see over here the software requirement specification document by the IEEE standard. Uh, this is the contents of the SRS document. You can see over here introduction to the document, then general description of the product like product functions, user side characteristics, constraints, assumptions and dependencies. Next point is specific requirements like external interface requirements, user interfaces, hardware interfaces, software interfaces, communication interfaces, functional requirements, and the performance requirements. Then design constraints, quality requirements, and other requirements. Now let us see the validation task. The requirement documents are both as a contract between us and the customers, detailing what we are to deliver and as guidelines for the designers detailing what they are to build. Before the requirements can be turned over to the designers, we and our customers must be absolutely sure that each knows the other's intent and that our intents are captured in the requirements document. To establish this certainty, we validate the requirements and verify the specification. In requirement validation, we check that our requirements definition accurately reflects customers, actually all the stakeholders and their needs. Requirements validation. Below are the characteristics of validating the requirements. The requirements must be correct, consistent, unambiguous, complete, and relevant. Let us see the checklist of requirements validation. It is often useful to examine each requirement against a set of checklist questions. Here is a small subset of those that might be asked. Are requirements stated clearly? Can they be misinterpreted? Is the source uh, is the source, for example, a person, a regulation, a document of the requirement identified? Has the final statement of the requirement been examined by or against the original source? Is the requirement bounded in quantitative terms? What other requirements relate to this requirement? Are they clearly noted via cross-reference matrix or other mechanism? Does the requirement violate any system domain constraints? Is the requirement testable? If so, can we specify tests, sometimes called validation criteria, to exercise the requirement? Is the requirement traceable to any system model that has been created? Is the requirement traceable to overall system or product objectives? Is the specification structured in a way that leads to easy understanding, easy reference, and easy translation into more technical work products? Have the requirements associated with performance, behavior, and operational characteristics been clearly stated? What requirements appear to be implicit? Last task about the requirement management. The requirements for computer-based systems change, and the desire to change requirements persist throughout the life of the system. Requirements management is a set of activities that help the project team to identify, control, and track requirements and changes to the requirements at any time as the project proceeds. Begins with the identification. Each requirement has a unique identifier. Traceability tables are developed. Feature traceability, source traceability, dependency traceability, subsystem traceability, and interface traceabilities are being used. Many of these activities are identical to the software configuration management techniques. Before moving further, let us pause the video, think, record in your notebook that there is a need to prioritize the requirements. Let us compare your notes with the upcoming description in the slides. So priorities help you in concentrating on most important user and customer requirements. It helps you in focusing the development effort, manage the projects more effectively, plan for stage deliveries, and it also can help you making the acceptable trade-off among conflicting goals as well as allocating the resources properly. Let us talk about prioritizing requirements in much details. Requirements are prioritized to minimize risk during development so that the most important or high risk requirements are implemented first. Prioritization means balancing the business benefit of each requirement against its cost and any implication it has for the architectural foundation and future evolution of the product. There is a need to explore how delivering delightful service can drive continual improvement, customer loyalty, and subsequently the business success. Several methods for assessing a prioritization of software requirements does exist. One of the effort is the Kano model, which is a theory for product development and customer satisfaction developed in 1980s by Professor Noraiki Kano, which classifies customer preferences into five different categories, out of which we'll be looking into three main categories like must be quality, one dimensional quality, and attractive quality. Must be quality are the requirements that the customers expect and are taken for granted. When done well, customers are just neutral, but when done poorly, customers are very dissatisfied. Kano originally called these must be's because they are the requirements that must be included and are the price of entry into the market. For example, in a hotel, providing a clean room is a basic necessity. In a call center, greeting customers is a basic necessity. The one dimensional quality. These attributes result in satisfaction when fulfilled and dissatisfaction when not fulfilled. These are attributes that are spoken and the ones in which companies compete. An example of this would be a milk package that is said to have 10% more milk for the same price will result in customer satisfaction. But if it only contains 6%, then the customer will feel misled and it will lead to dissatisfaction. Then customer will never buy that milk package. Third one is the attractive quality. These quality attributes provide satisfaction when achieved fully but do not cause dissatisfaction when not being fulfilled. These are attributes that are not normally expected. For example, a thermometer on a package of milk showing the temperature of the milk. Since these types of attributes of quality unexpectedly delight customers, they are often unspoken. For example, in a call center, providing special offers and compensations to customers or the proactive escalation and instant resolution of their issue is an attractive feature. In a hotel, providing free breakfast is an attractive feature. This is a diagram for the Kano model. It identifies the non-linear relationship between non-linear relationship between the performance and the satisfaction of a customer. According to this Kano model, there are five different ways of the customer satisfaction. Must be attribute fulfill the basic functions of the product. Customers see these attributes as prerequisites, will be highly dissatisfied if these attributes are not present or their performance is inadequate. On the other hand, these attributes do not bring satisfaction, being present or having sufficient performance to customer satisfaction. This is the one dimensional attribute. One dimensional attribute are directly related in terms of their performance to the customer satisfaction. The higher the attribute's performance, the greater the customer satisfaction, and lower the attribute performance, lower the customer satisfaction. Another is attractive attribute. It brings about superior satisfaction when their performance is higher. However, they do not bring dissatisfaction if their performance is low. There are two other types of attributes which can be identified in Kano model are neutral and the reverse. The neutral attributes do not bring about satisfaction or dissatisfaction, while reverse attributes bring about more satisfaction by their absence than their presence. Let us see must be quality attribute in much more details. One of the main points of the assessment in the Kano model is the threshold attribute. These are basically the features that the product must have in order to meet customer demands. If this attribute is overlooked, the product is simply incomplete. If a new product is not examined using the threshold aspect, it may not be possible to enter the market. This is the first and most important characteristics of the Kano model. Threshold attributes are simple components to a product. However, if they are not available, the product will soon leave the market due to dissatisfaction. The threshold attributes are most often seen as as a price of entry. Many products have threshold attributes that are overlooked. Since this component of the product is a necessary guideline, many consumers do not judge how advanced a particular feature is. Therefore, many times companies will want to improve the other attributes because consumers remain neutral to changes in the threshold section. Another is a direct or linear attribute, which is one dimensional quality attribute. A performance attribute is defined as a skill, knowledge, ability, or behavioral characteristics that is associated with the job performance. Performance attributes are metrics on which a company bases its business aspirations. They have an explicit purpose. Companies prioritize their investment decisions and efforts and explain their strategies using performance attributes. For example, in retail, the focus is generally on assuring availability of the products at best cost. Performance attributes are those for which more is better, and a better performance attribute and a better performance attribute will improve customer satisfaction. On the other hand, a weak performance attribute reduces customer satisfaction. When customers discuss their needs, these needs will fall into the performance attributes category. The price a customer is willing to pay for the product is closely tied to performance attributes. So, the higher the performance attribute, the higher the customers will be willing to pay for the product. Another quality attribute is attractive quality attribute. Not only does the Kano model feature performance attributes, but also additionally it incorporates an excitement attribute as well. Excitement attributes are for the most part unforeseen by the client but may yield highest satisfaction. Having excitement attributes can only help you, but in some scenarios it is okay to not have them included. The key behind the Kano model is for the engineer is to discover this unknown need and enlighten the consumer to the sort of engage that wow effect. Having concurrent excitement attributes within a product can provide a significant competitive advantage over a rival. The more the customer thinks about these amazing new ideas, the more they want it. Out of all the attributes introduced in the Kano model, the excitement ones are the most powerful and have the potential to lead to the highest gross profits margin. In continuation to prioritizing requirements, we have seen the Kano model or Kano diagram. Now we will look into the cost value approach. The cost value approach is an analytical method for prioritizing requirements based on ranking candidate requirements in two dimensions. First dimension is their value to the customer and users, and another dimension is their estimated cost of implementation, which is known as a cost value approach. Let us see the process of cost value approach. There are 5 steps into prioritizing the requirements using cost value approach. First one, the requirements engineers carefully review the candidate requirements for completeness and ensure that they are stated in an unambiguous manner. Second is customers and users apply analytical hierarchy process pairwise comparison method to assess the relative value of the candidate requirements. Experienced software engineers use AHP pairwise comparison to estimate and relative cost of implementing each candidate requirement. A software engineer uses AHP to calculate each candidate requirement's relative value and implementation cost and plots these on the cost value diagram. The stakeholders use the cost value diagram as a conceptual map for analyzing and discussing the candidate requirement. You can see here this is a figure that shows the value on y-axis and estimated cost on the x-axis in percentage format. So you can see when the candidate requirements are being divided into low priority region, medium priority region and high priority region. Basically AHP uses, we compare each requirement with another requirement. So if you have 3 requirements, you can build a matrix of 3 by 3 by using this scale for pairwise comparisons. If the two requirements are of equal value, you can put a relative intensity as I have shown over here. And if one requirement is slightly more having more value than the another requirement, the value can be 3 or something. So you can use the relative intensity from this particular table and you create a matrix, and after that you can create the AHP values. On the basis of that, you decide like if that particular requirement comes into this particular region, so you can say that particular candidate requirement is of high, medium and low low priority requirement. These are the two basically priority requirement methods. One is Kano and cost optimization.